Hello. So we've seen sort of a video on how to do implicit differentiation and sort of the mechanics of implicit differentiation. But a fair question is sort of why would we do implicit differentiation, right? Like what are some sort of use cases, examples of these kinds of things? So we have the techniques, right? We've developed the technique of doing the process, but we want to know what are some sort of places where this is useful. And it turns out that really implicitly defined functions are considerably more common than you might think. Like it might seem like a very sort of specific area, like a very particular thing that you might have to encounter once in a while. But it turns out that it happens a lot. So I guess the question then is sort of why? Like where is that coming from? So the vast majority of implicitly defined functions, they come from one of two places. Not all, but the vast majority. So the first place, and we'll give examples, or at least an example in this video for each of them, but the first one that sort of occurs is when the nature of the relationship isn't sort of directly attainable or isn't sort of explicitly something you can write down for like an explicit function. So for example, we might just have some sort of mathematical model that shows a correlation between two variables, but not necessarily sort of how one dictates the other. Another example, or another sort of way that this comes about, is because you have this sort of implicit relationship from the fact that although the thing you want may look explicitly defined, what you are looking at and thinking of as inputs are really themselves functions of some other sort of hidden input. And we'll see sort of an example of that as well. So for the first one, it's sort of very common to happen in economics. So in particular, in economics, you often get sort of data sheets or sort of example or information that's just sort of a bunch of points, right? So for example, we might see something that relates price and quantity, and the problem is that you have all these individual data points. You can use sort of statistical modeling to create sort of a best fit line, which is not something we're doing in this class, but this is a thing you can sort of build a model that sort of goes through all these data points as best as possible, and you get some sort of function, but that function is often implicitly defined, right? So for example, we might get something that looks like this thing here, this p squared minus pq minus 2q squared equals k, bunch of letters. But really, right here, p is the price of the object that you're sort of putting in, q is how many that you are selling, and k is just some number that comes out of that sort of statistical modeling piece, right? The important bit here is that p and q are the sort of unknowns, and maybe you want to treat sort of one of them as the input and one of them as the output, right? You want to say like, oh, if I'm going to try to sell this many things, what should I charge? Or if I'm going to charge this amount, how many things can I expect to sell? All right, so you go either direction, but you can't sort of isolate either one of those things, okay? So sort of in particular, right, if you have this sort of data sheet, you get a best fit model. That model is telling you information about the situation you already have, right? It's saying you sold 500 things, they cost $5 a piece. Like that's the relationship between those two numbers. And you sort of build this model that sort of gives you a little bit of information. But what if you want to tweak that, right? You want to say like, okay, I want to know how much, a small change in price will change the demand. Because if I increase price a little, maybe that means the demand goes down, but maybe I still net more money, right? More profit. So this is exactly where derivatives come into play, is that derivatives are there to sort of analyze small changes. That's what they're really good at. And in fact, this sort of example, like this particular example in economics, is so common that it actually has a name. This is called price elasticity or demand elasticity. So the idea is that you sort of stretch it a little or contract it a little and see what happens with derivatives in order to get an idea of like, can I make more profit, less profit, what's going to happen, right? So this is an example of one of those sort of, you can't necessarily directly get an explicit formula for what you're trying to do, but nonetheless, we can still analyze to tell like, okay, what happens if I sort of want to tweak one of the inputs and see how that affects the other piece, okay? Now, the other example, right, where I was saying sometimes you get some output that is sort of looks explicitly defined, but turns out not to be because there's sort of some hidden thing at play. So what if we want to determine the impact of like rushing an order, right? We have some, we have company and the company is selling things and we're under contract to sort of have something done by a deadline. Something happens, we need more than normal, so we try to rush the factory to sort of get that order filled. So in this case, we will still have some sort of price function, and that price function may look explicitly defined, but actually there's a hidden piece here. So in this case, we're talking about rushing, right? There's this underlying idea of time. So for example, we could end up with something that looks like this. We have P equals 5L plus 3M, where P is price, L is labor, and M is material cost. Now, the thing is that like labor cost isn't just like 5, right? Like labor cost is a complicated thing all on its own. You have, overtime versus regular, amount of working hours. So if you rush the, past a certain threshold, then you're going to have sort of a per hour increase. And likewise, you have overhead for the actual labor aspect of it, like, having managers and things like this. And likewise, material costs, right? So you have a certain sort of process of making these materials, and whether or not you can rush that process of making the materials also depends on, available machinery and all kinds of things. And so really, both of these things are sort of dependent on some hidden pieces of information that aren't made clear in this sort of rather simplistic end result, right? So often a model, this is really almost always the case with a sort of cover sheet equation model, is that they sort of broke down all of the process, which in an actual business report is usually what most of the report is after that cover sheet, is figuring out what actual thing is L and M. And then on the cover sheet, they're sort of like, this is the summation of those 30 hours of work is we've decided it's 5L plus 3M. And these L's and M's are sort of this nebulous thing unless you dig into the guts of the report, right? So this is why if you want to tweak something, right, you want to say, okay, I want to change the price a little, or I want to see what happens if I'm going to give everybody a small raise. Does that sort of motivate them in some way? Or, if we switch to a cheaper or more expensive material, how is that going to affect price? And, all of these things, those small changes, again, exactly what the sort of derivative is for, and trying to take a derivative sort of naively of this thing is sort of, it is inevitable that you're going to have to worry about the fact that these things themselves are complicated sort of functions in the background, and thus use implicit differentiation, okay? So what do we do? So in this video, we saw a couple of sort of common, surprisingly common real-world instances where this implicitly defined functions, these things crop up, and why it would sort of be natural to take derivatives of these things, right? It's not just enough that like, yes, we have implicitly defined functions out there in the wild business world or whatever, right? Why would you care about being able to specifically take a derivative? And it turns out that that is almost inevitable because you usually want to know small tweaks and how those affect things, right? And sort of as a end result, as an end conclusion, right? Implicit differentiation seems like it might be a tool that's too specialized a tool to use, but in practice, it's actually more common to run into, I would argue, at least in the business world, is more common to run into situations that are implicitly defined than explicitly defined. So it comes up much more often than you might think. Okay? So that's that.